This here is lesson 4. We are going to do some what we call predicting and balancing chemical half reactions. Predicting and balancing chemical half reactions. Here we go. Okay. Half reactions, redox reactions. Okay. We're going to look at something called the 5-step method. And we'll use this a couple times throughout the year here. And this one, like I said, is probably something we will use a few times here, and they're kind of roughly all the same here. The first step you're going to do today is you're going to list out all the major, what we call species, or basically just fancy word for atoms, ions, or molecules. You're going to list out all the things that are possible in this chemical reaction, okay? Listing out all the possible things, atoms, ions, molecules in this chemical reaction. That's step 1. You are going to identify the SOA, which of course is the one that's being reduced. Yes? So you're going to identify which one is being reduced, and the strongest one at being reduced. Okay? And then you're going to identify, and you're going to write out its half reaction, reduction half reaction, of course, because SOAs are a reduction half reaction, yes? Okay? And you're going to identify the SRA. In other words, you're going to write out the oxidation half reaction. Okay? Now, is there other things going on here? Yes, there is. But if you put, a reducing agent and an oxidizing agent together, it's going to be the strongest oxidizing agent that reacts with the strongest reducing agent. Makes sense, doesn't it? It's going to be the one that wants to give off the electrons the best is going to react with the one that wants to take the electrons the best. Yes? Because why would you bother with the weaker ones? It's going to be more difficult. Okay? So you're going to do the SRA and the SOA as part of the reaction here. Those are the 2 half reactions, and then we're going to write out the redox reaction as part of this. Now, really, after the first step, it's exactly what we just went over for homework. It's writing out the reduction half reaction, the oxidation half reaction, balancing the electrons, and writing out the final reaction. That's all it is. Okay? So the first step's a little different, though. So that's what we need to worry about. Step 4 in this 5-step process is you're going to balance out the reactions and write out the net ionic equation by adding the 2 half reactions together. And finally, you're going to classify this reaction as spontaneous or non-spontaneous. If it's spontaneous, how do you know? What's the terminology from yesterday that we used? Spontaneous. Oxidizing agent is higher top left than the reducing agent, yes? So it has to look like this, correct? And if it's non-spontaneous, it looks like this, yes? So, spontaneous, that's what we're going to go with, okay? Or it could be non-spontaneous as well, but we'll see, okay? Okay, so if the SOA, SRA is a combination of chemicals, all parts of the combination have to be present, okay? So, in some cases, it's not just simple like we did for homework the other day. It's a little bit more complicated than that in some cases. We have to make sure that if we're going to use this, we have to make sure that if there's anything else that we use in that chemical half reaction, we need to use that as well. Okay? And actually the first example is going to do that for you and show you what I mean. Okay? So you have to make sure everything is present there for that half reaction that's going to be required. Okay? So, first example is this one right here. This is where I need you guys to help me out here. Okay? So, you guys have this example here. I'm just going to scooch it down to the bottom here so I can write. It says here, okay, what redox reaction takes place when a solution of bleach, which is actually made up of sodium hypochlorite, reacts with a solution of potassium iodide? Give me some things here. What's involved in this reaction? You tell me. I'll wait for you. What are some of the things that you see there? I'll disagree with you there, because it's not quite right. Close. Give me some options, guys. Read it. What does it say? Bleach. Yeah. What else? Potassium iodide. Okay, before that, what else do you see? It's not actually a compound. Solution. What does a solution mean? Solution. Liquid what? What do you use to make a solution? Water. Write down water. There's a reason I want you to list that one first, because that'll help you with the rest of these now. Okay, now listen. Yeah, we're making a solution of bleach and a solution of potassium iodide. So we got some water, yes? Okay. When you put sodium hypochlorite into water, what do you get? Chem 20. We've talked about it here before. Nope. Nope. What happens when you put sodium period 1 got this. Sodium hypochlorite into water. You get what? Yes, we already did that. Oh, wow. When you put an ionic compound into water, it undergoes what process? Yes. What does that mean? It splits up into what? No. Sodium ions and? Yes, hypochlorite ions. Hypochlorite ions look like this, ClO minus. Okay? Yes? Come on, you guys. Wakey, wakey. When you put potassium iodide and you mix that with the solution of potassium iodide, what do you have there? Potassium, I'll just do it for you because you're bordering on, I don't know what I can't say it. Just a minute here. All right, so you get potassium ions and iodide ions. Yes? Okay. Now, what you have to be able to do is you get your data booklets out and you have to look for these things in a table. Okay? And that table is right here. It is page 7. And on that table, you will see a list of reduction half reactions. Hey, reduction half reactions. And that's all it says, reduction half reactions. By the way, let me ask you a question. Looking at this table here, just stop for a second what you're doing. What's the top left one? What is F2? Is that not the SOA? You betcha it is. Which is the SRA on this table? Lithium. Okay? Lithium solid, yes? Okay? So, this is exactly what you guys have done yesterday. Except now you got a bigger table to pick from, and I didn't give you a list of tiny little reactions, because that list of tiny little reactions is what you guys are going to come up with here. In fact, you only need to worry about 2 of those little tiny reactions. Okay? So, looking in the top left is how you do this. Listen closely. This is a super duper important, and you're going to do this for the rest of your chemical career. You start in the top left, and you start working your way down until you find one of these things or a combination of these things. Exactly what you see here. Exactly. Okay? There's no room for interpretation here. That's why step 1's kind of important, which you guys failed miserably. Okay? Because I had to basically prod it out of you. That's okay. It's your first one. I'll forgive you this time. Although we have 2 more examples. What do you see here that matches up with something there as you start in the top left and start working your way down? What's the first thing you see? And you want to pick the first one because that's going to be your SOA in this chemical reaction. What is it? It is, oh geez, I always, you know what, I have to admit, I'm not, I always misplace these ones here. Where is it here? I just had it last period. There it is. Okay. So, have you guys found it? Is it this? Yes. They write it as OCl minus, but ClO minus, same thing. Okay, hypochlorite can be written 2 different ways. It's actually on your periodic table as well. look for those two things, top left starting your way down. That's the first one you run into. That's because it's the first one in this reaction. So therefore, in this particular reaction, this is, you're going to label it your SOA. Okay? If it's your SOA, it's being what? Reduced. So you're just going to write this equation out. It's that simple now. You just look at that. You just copy it down. How hard is that? Okay? It's a lot harder to say it, apparently, than it is to write it out. Although I might screw that up, too. Okay, and H2O. And 2 electrons gives me, I don't need to use the double arrow because this is a reduction half reaction. Okay? Yes? Cl minus and 2 hydroxides. Now it is super duper important, because I did this first class and I have a habit of this actually. I get a little excited about this. This is fun for me. Okay? It's like a little scavenger hunt. And I get excited, and sometimes I don't write down exactly what it is because I forget numbers out in front. Like first period, I forgot the 2 hydroxides. I just wrote down hydroxide. Thankfully, somebody pointed that out to me. Okay? You can check at the end when you're done too, by the way, and we'll get to that eventually here. Okay? Good. That's done. That's all you got to do. That's your reduction half reaction in this particular set of circumstances here, this particular equation. Starting at the bottom right and starting going up. Because remember, the SOA is up here, and we went down until we found it, yes? You start in the bottom right, okay, and start working your way up, because that's your SRA, yes? The strongest reducing agent is lithium, right? And if you go up from there, they obviously get a little bit weaker as you go along. But, you know, it depends on what you have in this particular one. So what is it? No. I just told you, you got to find the one that matches up exactly. That's potassium solid. Do you have potassium solid up here? No. Keep looking. Yes? Nope. Do you see Ag up there? Nope. It is what? It's not the iodine. Iodide? Yes. You're going to go all the way up until you find that one. Okay? Yeah, it is far. It's okay. And you're not going to write it down exactly like you see it there, because you'd be writing down another reduction half reaction. That doesn't make sense, because you'd have electrons on both sides. So you got to flip it around. That's why they have double arrows there, so you can flip it around. And you're going to write down this instead. 2I minus aqueous gives me, notice how I line up the arrows, because I like things nice and neat, because you're chemistry students now, hey? Well, you were last year too, but now you're Chem 30 students, and you like things nice and neat, because you're chemists. And you get I2 solid and 2 electrons. Okay? Good? Yes. Okay? There's no room for interpretation here, guys. That's why you do the first step. That tells you. You're going to add these up. Look, I gain 2, I lose 2. Perfect. I don't even have to multiply. This works out well. Add them up. Redox. OCl minus and H2O liquid and 2I minuses gives me Cl minus and 2 hydroxides and I2 solid. Okay? Add them up. Yep. Because potassium is a solid. We don't have potassium solid. We have potassium ion. On the left side it does, but not on the right side. No, well, no, because, well, yeah, but this is on the right side. Yes? If you want to use K solid, or if you want to use K, well, you can't use K solid because we don't have any K solid. We have potassium iodide. If you want to use this one, well, that's on the left side. It's being reduced, right? We didn't pick that one because it's not the strongest one. Okay? Now, how do you know if you did it right? I'll give you a hint. You can check all these tonight. You can even mark your own quizzes if you want, which you'll never do. But OCl minus is 1 minus, 0, 2 minuses. On this side, get a calculator if you can't do this in your head. 3 minus, yes? 1 minus and 2 minus, 3 minus. Oh, left side equals right side. How about that? Is it balanced? It better be. O and O, that's 2. I got 2 O's. Cl, Cl, check. 2 H's, 2 H's. 2 I's, 2 I's. Looks good to me. Okay? Done. Good job, Batchy. Way to go, coach. Hey? Good? Yes? Okay. Now, we can make observations of what would happen here. Unfortunately, I don't think we're going to have time because you guys took forever on the first one. So we are going to do that Monday. I'm going to do that with the other class too. Okay? We're probably going to do that a little bit on Monday. If I have time, I'll come back and do that. By the way, before I forget, spontaneous or non-spontaneous reaction? Look back in your booklet. It's spontaneous. So you're going to put a spont up there to let me know it's spontaneous. Okay? And like I said, there is some things that you can observe when this reaction takes place. When you mix all this stuff together, you'll see stuff happen. We will talk about that. Probably not today. Yeah. Well, top left, bottom right. Yeah. No. Reduction, oxidation. Look where the reduction is. Look where the oxidation is. Spontaneous. Okay, here we go. Good? Okay, I think we're a little bit behind here, so we're picking up the pace. Now, listen. Okay, guys, quiet, please. We got to get through this. Every spontaneous reaction shows change of evidence. We'll talk about that. What they're talking about is observations. What would you see happen? What's some proof, evidence that this reaction has taken place? We will do that probably, like I said, Monday. Okay? And if we have time, I'll do some today. But every spontaneous reaction, and you're going to predict what happens. And that's important because that will be diploma questions. Guaranteed. Let's look at this one. I want you guys right now, real quick, look at this one. And I want you to tell me, start writing out some stuff here. What do you see taking place here? What are some of the things that we need involved here? Do it now. So, step 1, write out all the major species. What are they? Huh? H2O. Thank you. That's 1. What else? Huh? K solid. Yes, a solid chunk of potassium. What else? What else is there? Come on, guys. Anything else? No. Okay, I'm just testing you. That's all. Okay. Sorry. That's all. Okay, that's all you got in this one. So, now we need to find these two. Now, I know we already kind of talked a little bit about potassium, but I still want you to keep the same pattern. Start in the top left, start working your way down, because I know it's probably, some of you guys already picked up on this, it's maybe obvious for this one. I get that. But you always, trust me, go with this, because they're not going to be this easy, okay? Start in the top left, start working your way down until you run across one of these two things. You only got 2 things to pick from. Well, eventually, quite a ways down here, where is it here? Once again, H2O, where is it? There it is. About, I think it was 12 from the bottom, roughly. I find my SOA, yes? About 12 from the bottom, quite a ways down there. And the reaction looks like this, and of course this will be a reduction half reaction. And it looks like this, 2 H2Os and 2 electrons gives you H2 gas and 2 hydroxide aqueous. Okay? So you write that out exactly like it is. Okay? Don't try and switch stuff. Don't try and be a hero. Okay? You don't need to be a hero today. You just need to write it out. Oxidation. Okay? We already talked about this one, so you probably should know, right? But now we start in the bottom right, and you start working your way up. And of course, the first one you see is potassium solid. So potassium solid gives you potassium aqueous and 1 electron. That's not an aqueous. All right? Now, pretty straightforward, yes? You guys follow me here so far? You good? Yeah? Yeah? We need to add these up. Before we can add them up, though, you have to ask yourself, does electrons gained equal electrons lost? No. So this is kind of back to, like I said, first day we did this. Got to balance them. Times it by 2. Right? Electrons lost has to equal electrons gained. Red ox reaction. 2 H2Os Simply add this up, guys. 2 potassium solids gives me H2 gas and 2 hydroxides and 2 K pluses. Okay? And before we go any further, spontaneous or non-spontaneous? Spontaneous, yep. Always higher than the RA, right? Now, it will not always be spontaneous. Okay, I think the 3 examples we have for you today are. In fact, I think it tells you in this question that it is a spontaneous reaction. Doesn't it? If you read it, it does. So if you read closely, it kind of tells you some things, right? Reading's important, apparently. Does left side equal right side? Everything good here. Let's see. 4 H's, yeah. 2 and 2, 4. We got 2 O's, yeah. 2 potassiums, 2 potassiums. This is 0. This is 0, 2 minus, 2 plus. Good. Check. Done. Okay? And if we have time, we'll go back and talk about things you would see. Yeah. Well, you have to, because if you don't flip it, it's another reducing equation, right? We already got our strongest one, so we don't want another reducing one. We want an oxidized one, right? So we got to flip it. Yeah.
So when a non-spontaneous means you have like lithium, like aqueous at the very bottom left, and you have fluoride, aqueous at the top right.
Yeah.
Those two that would be non-spontaneous.
Yeah.
The right sides.
Yeah. Okay. Good. Moving on. Last one here. Now, this one here says list 3 observations. That's what I'm talking about. We'll talk about that if we have time here, which we actually might here today. So talk about that, but I want you guys to start going on this one here. So same thing. I want you guys to come up a list. When you read that, it says a copper penny is placed in. I'm going to make sure we have time for this. So, okay, what do you want to put down here? What's a list of stuff? Yep. H2O, probably a good one. We're going to come back to that one in a second here. What else? Copper what? Okay, copper solid. What else? That's it? No, I disagree. Nope, not quite. You're missing something. Yep, I'll go with that. What else? Oh, come on. Huh? Nope. Thank you. H plus aqueous. Okay. Now, listen. First of all, how many people know what nitric acid looks like? You should have known from Chem 20. If you don't, you look in the data booklet. It tells you in there, yes? So no excuses. Okay? Look in the data booklet if you don't know, because it's in there. Is nitric acid a strong acid? Look in the data booklet if you're not sure. It tells you it's the top 6 are strong. Okay, it is. When you put, listen, why did you pick, well, first of all, why did we pick water, Emily? Why did you pick water? Okay, and to make an acid you need water, yes? Because without water, what is it? HNO3, right? What does water do? It does what? No. It's the wrong term. Right idea, but wrong term. It. Why would you say that? It what? Not dissociates, it. I'll just tell you because this is going nowhere. Cassidy's going to tell you. What do you mean, no? Taylor. Come on. Who's going to tell me? Who's going to save the day? Dissociation. We studied separation. That's not it. And there's one more. Oh, don't even. Yeah, the acid combusts. Yeah. Come on. Ionization is the correct term. Period 1 got that, for crying out loud. Hey? I'm not saying anything about period 1, but they were on the ball this morning. They were just firing stuff off, I tell you. You guys, not so much. Hey? Okay, listen. The water is there. Okay, listen. Shh. The water is there because the acid ionizes into ions. Yes? Okay? That's how we get the H plus and NO3 minus. If the water wasn't there, do I get H plus and NO3 minus? No. Okay? It's just a molecular compound. Because we put into water, the water's polar, pulls it apart, H plus, NO3 minus. It's a strong acid, right? So it breaks up completely into ions, yes? Okay? I have 100% ionization. We talk about that in Chem 20. Yeah? All right? Complete ionization. All acids need water. Water because it has to break into ions. Okay? Ionization is the process. Here's a list of your stuff. What are you going to start with? Top left, start working your way down. Which is the SOA? And the answer is yes. Anything else I need with that one there? No, that's it. So you're going to write that one out. It's about, I think it's about 14 down on the top left, obviously. Reduction half reaction is 2 NO3 minuses and 4 H pluses and 2 electrons equals N2 O4 gas and 2 H2O liquids. Okay? So that's your reduction half reaction, yes? Good? AKA, that's your SOA. Strongest oxidizing agents are those two there, combined together. Oxidation half reaction, bottom right, start working your way up, okay? And remember, you got to find exactly what you see up there. There's no, you can't start making stuff up, okay? No. So if you start there and work your way up, you're going to run into eventually copper solid is the first one you'll get to. So this is your SRA. You're going to label these, please, so I know quickly if you've done this right or not. Copper solid gives you copper 2 plus and 2 electrons. No. Which one? Yeah, no. Where are you guys looking? How many from the, what's the number on the right-hand side that you're talking about? Huh? I know he's wrong. Yeah. Well, it's not on the right-hand side. I don't know where you see this. Where do you see this? Which one are you looking at? Well, H2 and 2OH, do you see that up there? All right, I just finished telling you. You can't make stuff up. That's the stuff we're working with. That's it. Okay? You want to make stuff up, go to art class or something. I don't know. I don't know what that has to do with art class, but go to there anyway. Okay? 2 NO3 minuses. By the way, 2 electrons, golden, right? Sweet. Aqueous. 4 H pluses. Don't forget to balance the electrons, because that's what most of you guys are going to have, or that's what you're going to have to do today on most questions probably. Gas and 2 H2O liquids and copper 2 plus aqueous. Okay, basically just write down what you have. Spontaneous or non-spontaneous? Spontaneous. Okay. Good? Okay. Questions, anyone? Yes? Yeah, we're getting there. If we have time. What, do we have time? I think we do. We get to 32. We're golden. Okay? Okay. What? Don't we? What are you laughing at? Yeah, we're good. Okay? Listen. Okay. Now, with these reactions, okay, when these reactions take place. They're going to ask you, what are some of the things that you would expect to see, or what are some observations you could tell? Okay, we're just going to start with this one right here. Okay, I think we'll have enough time to do this, and then you guys can do this because this is probably going to be part of your homework too. Well, let's take a look at what we have here. Look, do you know anything about NO3 minus? It's an ion, right? In water. Are you going to see it? Probably not. Nitrate doesn't really have a color to it or anything like that. What is this? What's H plus? Oh, this is not a trick question. It shouldn't be. H plus is, yeah. What is it? Huh? H plus is not a gas. Wow. We got a long way to go with you guys. H plus is an acid. It is what makes an acid, isn't it? All acids need to have hydrogen ions, do they not? Yes. Or, if you're not happy about that, hydronium ions, which is what attaches to water, yes? We'll get back to hydronium later. For right now, H plus is acids, yes? So, and what's this? A solid chunk of copper. Pay attention. So you got acid. pH would probably be fairly low. A solid chunk. So that's what you'd start out with. What happens on the other side? You get N2O4 gas. What does gas look like? Bubbles, perhaps? So you would say bubbles start to appear. Okay? Or bubbles are formed. Okay? H2O liquid and copper 2 plus. Look at the left side versus the right side. What's different between those? Left side versus right side. Let me focus you back in on this part right here. Look at the right side. What do you notice? Turns into water. Water is neutral, right? So you would expect what to happen to the pH of this? The pH would probably increase to neutral-ish. Okay? How much it goes up, I don't know exactly. It really depends on how much actually goes on there. But you would expect the pH to go up because now it's going to more neutral. There's no more H plus. Now it's water. Okay? Neutral. So pH would increase to something around neutral, perhaps around 7. What else do you notice here? Here's another observation. Copper solid. What's on the right side? Copper 2 plus aqueous. What happens to the copper solid? Dissolves, gets used up. So I would expect the copper solid mass, you could say, to decrease, yes? In other words, to get used up. That copper would start to disappear. What appears on the right side is copper 2 plus, aqueous. By the way, copper 2 plus aqueous, when you look up in your data booklet here, this is pretty handy for you. Second last page in your data booklet tells you that copper 2 plus, and you know this from the lab last day, copper 2 plus looks like what? This is what I'm looking at. Copper 2 plus has a unique blue color to it, yes? So, you would expect a blue color to appear, yes? A blue aqueous solution would start to form, okay? Which you wouldn't have initially, because look what you have initially. Nitrate. Is a nitrate one of these on here? No. H plus, can you see H plus ions? No. What about copper solid? Well, that's a solid, okay? That's not, there's no color to that. So you'd have a clear solution changing to, this all right here is clear, and it would be changing to a blue solution with a gas, turning to more neutral. pH would start to increase, right, back up to 7. All these things are taking place here, Okay? And that's what you need to do. You need to look at the left side versus the right side. What if you have hydroxide in the equation? What does that mean? OH minus is what? Basic, right? So perhaps it goes from basic back to neutral, for example. Or maybe it starts out neutral and goes to basic. So what's happening to the pH, right? Yep. Usually, yes. You can look it up on here if you want. Yep. Okay. Look where most of the solids are. Look where the acid is, right? H plus. I mean, there's different acids, of course, so it depends on that, but most of the time, yeah. Okay. If you go back to this one here, we got a couple minutes here. You know, if we look at this one here real quick, what would I say about this second last one? What are you starting with? You're starting with water and a solid chunk, right? Over on this side, first thing I see is this. Look, it's changing, right? The mass of potassium solid decreases. That's the first thing I'd probably say. You're starting with a neutral solution to a basic solution. So pH would go up, right? Neutral is 7. If you have hydroxide, it'd be going up, right? Because it's basic. So pH would be increasing. What else? Gas is formed. Gas bubbles. Or, in some cases, perhaps just steam in some cases. But gas bubbles form. Okay, that takes care of that right there. That's 3. Potassium ion. Is there a color for potassium ion? Well, if you're not sure, look on here. Okay, there isn't. But, you know, you can always look on here and see. Okay? Whoa, 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 whoa. Sit down.